Hi friends, my name is Vivekanandan. I am a student of Sri Venkateshwara College of Engineering, Bengaluru. In this video, I am going to discuss about data processing instructions. Content: what is data processing instructions and types of data processing operations. Let's see first what is data processing instructions. The data processing instruction manipulate data within registers. The data processing operation include move instructions, arithmetic instructions, logical instructions, comparison instructions, and multiply instructions. If we use the S suffix on a data processing instructions, then it updates the flags in the CPSR. CPSR is a current program status register. Most data processing instructions can process one of their operands using the barrel shifter. Move and logical operation: update the carry flag C, negative flag N, and zero flag Z. The carry flag C is set from the result of the barrel shift as the last bit shifted out. The negative flag N is set to bit 31 of the result. The zero flag Z is set if the result is 0. Now let's see data processing operations. First, move instructions. It is the simplest ARM instructions. It copies N into a destination register RD, where N is a register or immediate value used to initialize a value or to transfer data between registers. Syntax: instruction, condition, S suffix, RD is a destination, N is a source or register or immediate value. MOV instruction: move a 32-bit value into a register. MVN instruction: move the not of the 32-bit value into a register. Let's see example of move instruction. This example shows a simple move instruction. The MOV instruction takes the contents of register R5 and copy them into register R7. In this case, the value of 5 and overwriting value 8 in the register R7. In the pre and post, in pre, before execution of instruction, in post, after execution of instruction. In the pre, R5 hold 5, R7 hold 8, move R7, R5, R7 is the destination, R5 is the source. Let R7 equal to R5. In the post, R5 hold 5, R7 hold 5. There is no change in R5 value, it remains same. R7 value will be changed after the execution of instruction. Arithmetic instruction used to carry out addition and subtractions of 32-bit signed and unsigned values. Syntax: instruction, condition, S suffix, RD is a destination, RN and N is a source or register. ADC: add 232-bit value and carry. ADD: add two 32-bit values. RSB: reverse subtract of two 32-bit value. RSC: reverse subtract with carry of two 32-bit values. SBC: subtract with carry of two 32-bit values. Subtract two 32-bit values. Let's see example of arithmetic instruction. This simple subtracts instruction subtracts a value stored in a register R2 from a value stored in register R1. The result is stored in a register R0. In pre, R0 hold 0, R1 hold 2, R2 hold 1. Sub R0, R1 and R2. R0 is the destination, R1 and R2 is a source. R0 equal to R1 minus R2 in post. After the execution of instruction, R0 hold 1 logical instruction. Bitwise logical operation can be performed using this instruction. Syntax: instruction, condition, S suffix, RD is a destination, RN, N is a source, and instruction. Logical bitwise AND of two 32-bit values, ORR instruction. Logical bitwise OR of two 32-bit values, EOR. Logical exclusive OR of two 32-bit values, PIC. Logical bit clear and not. Now let's see example of logical instruction. This example shows a logical OR operation between register R1 and R2. R0 hold the results. So in the pre, R0 hold the 0, R1 and R2 hold the hexadecimal value, and ORR instruction, R0 and R1 and R2. R0 is the destination, R1 and R2 is the source. In the post, after the execution of instruction, so R0 hold the hexadecimal values. Comparison instruction. Comparison instruction are used to compare or test a register. These instructions compare and update the CPSR registers. Hence, S suffix instructions are not there for this instruction. So, syntax is instruction, condition, Rn and N. Rn is a destination, N is a source. CMN instruction, compare negated. CMP, compare. TEQ, test for equality of two 32-bit values. TST, test bit of a 32-bit values. Now let's see example of comparison instruction. This example shows a CMP comparison instruction. In the pre, CPSR equal to so on. So in this you can see both the register R0, R9 are equal before executing the instruction. The value of the jet flag prior to execution is 0 and is represented by a lowercase z. In CMP instruction R0 and R9, R0 is a destination, R9 is a source. In this post, after execution, the jet flag changes to 1 or an uppercase Z. These changes indicate that equality. Multiply instruction. Multiply instructions multiply the contents of a pair of registers. Syntax: MLA condition S suffix RD, RM, RS, RN. RD is the destination, RM, RS, RN is the source. MUL condition S suffix RD, RM, RS. RD is the destination, RM, RS is the source. MLA instruction multiply and accumulate. MUL instruction multiply. Now let's see example of multiply instruction. This example shows a simple multiply instruction that multiplies register R1 and R2 together and place the result into a register R0. In this example, register R1 is equal to the value 2 and register R2 is equal to 2. The result is 4, then placed into register R0. In the pre, R0 hold 0, R1 hold 2, R2 hold 2. MUL instruction R0, R1, R2. R0 is a destination, R1, R2 is the source. R0 equal to R1 into R2 in the post. After execution, R0 hold 4, R1 hold 2, R2 hold 2. Thank you.